Hi everyone, this is Jack from Maths Forge, and in today's lesson we're going to be doing factorizing double brackets where the coefficient of x squared is greater than 1. So let's take a look at our first example. Here we're being asked to factorize 2x squared minus 8x minus 24. I can see immediately that there is a common factor of a 2 in all three terms. So the first thing I'm going to do is I'm going to factor out a 2 from all three terms, and it's going to look like this. X squared minus 4x minus 12. Now I can go ahead and factorize into two brackets this expression here, which is a quadratic trinomial, and the number in front of the x, the coefficient of x squared, is 1. So if we go ahead and do that, we're going to have the following. So we're going to have x plus 2 and x minus 6, because of course 2 multiplied by negative 6 gives us negative 12, and 2 plus negative 6 gives us negative 4. So these are the numbers. And of course, don't forget we have this 2 that we factored out earlier. And now for the final step, I'm going to multiply this 2 into one of the brackets. I'm going to choose to multiply into the x plus 2 since it's the closest one. So we're going to have 2x plus 4, and then brackets, and then we have x minus 6. So this should be our final answer. And if we check our answer, there it is. Now we're going to do a 2-star example. So for the 2-star examples, they're quite different. You cannot find the common factor of this 4 in all of the terms. And in this case, you can't find in any of the terms except for the first term itself. So how we approach this factorization is very different to how you'd approach normal factorization that result in two brackets. Step 1, you're going to want to multiply your 4 by your 21. So we're going to do 4 times 21. So the coefficient of x squared, which is this 4, multiplied by the constant, which is this 21. So 4 times 21 is going to give us 84. Now this 84, you're going to want to find two numbers that multiply to give you 84 and add to give you 19. And of course 19 is the coefficient of x, it's the number in the middle here. So these two numbers, I'm going to call them magic numbers. These two magic numbers that multiply to give us 84 and add to give us 19. What can they be? Well, I'm just thinking about all of the numbers that can add to give me 19. So 10 plus 9, which is 19, but 10 times 9 is not 84. So I know that if I do 10 plus 9, I'll get 19, but 10 times 9 will give me 90. So 10 and 9 don't work. How about 11 and 8? 11 and 8 add to give us 19, but they times to give us 88, so they don't work either. So now I'm going to add one more to this number here on the left. It's going to be 12, and I'm going to reduce this number by 1. It's going to be 7. 12 plus 7 is 19, and 12 times 7 does give us 84. So these are our magic numbers, 12 and 7. Now, once you've found your magic numbers, what you do with them is as follows. You rewrite the quadratic expression for x squared. But when it comes to the plus 19x part, you're going to break this 19x up into your magic numbers. So I'm going to have plus 12x, don't forget to include the x as well, and plus 7x. So these are our two magic numbers. And of course, we have the plus 21 at the end. So this first initial process is to just find out what to break your middle term up into. And of course, they're broken up into our magic numbers. Okay, so for the next step, you are going to want to factorize your first two terms of this long expression, and you're going to want to factorize your last two terms. So what does that look like? It looks like this. I can see that the highest common factor in my first two terms is 4 and x. I can take 4x out of the bracket, and we're going to be left with x plus 3. And now for the last two terms, the highest common factor is a 7, so a positive 7. I'm going to take that out, and we're going to be left with an x plus 3. How you know you've used the method correctly is when you reach this stage, if you have these two brackets that have the same values in them, so these two brackets are identical, it means you are doing this correctly. So for our final stage now, I'm going to take my terms outside of the bracket, so this 4x and plus 7, and they are going to combine to make one bracket. So it's going to be 4x plus 7. And the other bracket is going to be made from these two brackets here. Remember what I said? If they're the same, it means you've done it correctly. So our second bracket should be x plus 3. And this should be our final answer. If we check our answer, there it is. So I'll just very quickly go over that again. Step 1, multiply your coefficient of x squared. So this 4 by your constant, this 21. This gives us 84. Find two numbers that multiply to give you 84 and add to give you this central term here, 19. And we went through the numbers, we called them our magic numbers, and we found the numbers to be 12 and 7. Rewrite your expression with the middle term broken up into the magic numbers. And then factorize your first two terms into a single bracket, factorize your last two terms into a single bracket. Take the terms outside of these brackets, form them into one bracket, and the terms that are inside of the brackets, form them into a separate bracket. And this should be your final answer. Now let's do a 3-star example. Here I can see that there is a common factor of 2 in all three terms. So I'm going to go ahead and take that out. It's going to leave us with 3x squared plus 16x plus 16. Now I'm going to go ahead and use the method that we used in the 2-star example to factorize this expression here in the brackets. So step 1, multiply the coefficient of x squared, this 3, and the constant, this 16. So 3 times 16 is going to give us 48. Step 2, find two numbers that multiply to give you this 48 and add to give you the central term, 16. So I know that 8 plus 8 gives us 16, but 8 times 8 does not give us 48. It gives us 64, so it can't be 8 and 8. Okay, let's add 1 to this 8 and subtract 1 from this 8. So 9 plus 7 add to give us 16, but they do not multiply to give us 48. They multiply to give us 63. How about 10 and 6? They add to give 16, but they multiply to give us 60, so they don't work. 11 and 5 multiply to give us 55. That doesn't work. How about 12 and 4? 12 plus 4 is 16, and 12 times 4 is indeed 48. So our magic numbers are 12 and 4. So I'm going to go ahead and rewrite this expression here exactly as it is, but with the middle term broken up into the magic numbers. So we're going to have 3x squared plus 12x plus 4x. And then we have plus 16 at the end. Now I'm going to factorize my first two terms. So we're going to have 2 big brackets, 3x, and then we're going to have x plus 4. And then we're going to factorize the last two terms. So the highest common factor here is a 4. So it's going to be plus 4, x plus 4. And if we close the big brackets, we have the following. Now I know the terms outside of the brackets form to make one set of brackets. So it's going to be 3x plus 4. And now I know that the terms inside the brackets, the x plus 4 and the x plus 4, form the other bracket, which is just going to be x plus 4. And we close this fully. Now, since there are no further operations outside of these two brackets, we can take off the big brackets, and we're going to be left with 2, 3x plus 4, and then x plus 4. Now, you can choose which bracket to multiply this 2 into. So this 2 is being multiplied onto this expression. However, since these two expressions are also being multiplied together, the 2 does not distribute into both brackets. It only gets multiplied onto one of the brackets. I'm going to choose for it to get multiplied into the smaller bracket, as the larger bracket already has numbers attached to the x. So it's going to be 3x plus 4, and then 2 multiplied by x plus 4 is going to be 2x plus 8. And this should be our final answer in its simplest terms. And if we check our answer, there it is. It doesn't matter which order you have the brackets in, as long as the brackets have the correct numbers in them. And that's it for our lesson on factorizing double brackets where the coefficient of x squared is greater than 1.